This is Mike, KO4PDI, the ham fun guy. I am here in my backyard. We were supposed to get some serious storms this afternoon. I don't know when it's supposed to start. It hasn't started yet, but if you look behind me, you can see my Rohn 25 towers laying on its side. There's my satellite antennas down at the end, and I'll show you a better look at that. I have it set up so that I can raise and lower it in case there's going to be a storm. I just have to lower my 2-wire antennas, which I did. This wire you see right here, you can't even see it though. That's the 160 meter end fed. I am not on the air right now because of the fact that my tower holds up my wire antennas, and if I got to lower my wire antennas with the tower, yeah, you lose it. I did a little video earlier today talking about how I put the tower up on a tilt base. I did that on TikTok. If you follow me on TikTok, it's KO4PDI, the ham fun guy. You can follow me over there too. Yeah, I talked about it a little bit, but I'm going to do a little more detail right now for you. And let's take a look at the tower and how it actually works. So this is the winch hanging on the wall. The wire you see hanging is the wire that I hook up to the battery when I want to raise and lower the tower. And that is how I power that winch. It's a 2,500 pound winch I picked up at Harbor Freight. The block and tackle below is a pulley that can handle 2,000 pounds of pressure. Now, the cable goes back and forth 5 times, which, how can I put it? It lessens the load on each particular piece of cable. Now, if you look over here, we'll follow it down. You can see it goes to another pulley that's hooked up on a chain on the tower. Right there, that's how it's hooked up. And this here pulley, this I picked up on Amazon, this right here. There's 2 of them. There's one at the base here, at the top here, and there's one at the base. These are not individual pulleys. These are one pulley, so one piece of wire travels faster around it than the other piece. Now, if you look, let's see, that is a solar panel there. That is hooked up to my tower camera. There is a camera mounted right here. If you look down right there, there's the camera that's mounted, that I get a good look at the backyard when it's up in the air. And toward the end of the tower, you could see my dual WIMO antennas on a fiberglass mast. I really am not happy with the fiberglass mast, as it's highly affected by heat and cold. But if you look here, you could see I've now center mounted, or semi-center mounted, the 70 centimeter antenna there. And on the opposite side of the tower, you can see I've semi-centered. Hold on, let me get that camera up a little higher for you. There's the 2 meter WIMO that's mounted on the fiberglass antenna. If you look to the left of the antenna, you see some scratches in the fiberglass crossarm. Those scratches are where I originally had the antenna mounted, but if you notice, the clamp actually dug into the fiberglass and twisted. So one day I came out here and the 2 meter was pointed at the ground. Now, if you look just above my head, right there, that's the 20-pound elevation azimuth rotator from Yaesu, the 5500. The fiberglass crossarm goes right there, and that is the 70 centimeter antenna there. And you don't realize, when you're looking at it from my camera up on the roof, it doesn't look like it's this big, but it's pretty big. That fiberglass crossarm is 93 inches in length. So the antennas are pretty far apart, so they don't affect each other. And looking in the other direction, you can see the tower's resting on that step ladder and the table up above. And it's pretty high up. This is 6 feet above my head here. So when I want to work on it, I got to lower it down even further, but I really don't want to do that. Basically, this is just set in this position to deal with the wind that's supposed to be coming today. Here at the top of the tower, you can see these pulleys. These are the lanyards that I use to raise and lower my wire antennas. This one I have to replace because when I lowered it down, I noticed that it was beginning to fray. The 160 meter end fed is on this lanyard when I raise it back up, and on this pulley right here, you can see it right there, and that's going to go back up later. So it's always good when you have to lower the tower because you get to do a little inspection of all your stuff. And this is my 80 meter off center fed. The label has completely been bleached out. It had a Palomar Engineering label there, but look, this is tied onto a piece of parachute cord. And as I lowered it down, look what I found. Oh baby, you know what that means? It was going to come down at some point all by itself. So I'll go get some new parachute cord. I have some in the garage. I'll replace this piece completely now because it's beyond its usefulness. The wires on that antenna have been replaced once also because the mount that I had up in the tree back in the backyard, that parachute cord broke eventually. So this is the older parachute cord. I'll replace this before I put it back up tomorrow. And yeah, and maybe we'll get it. Now you can see, you get a good shot of the satellite antennas at the other end of the tower. The base of the tower, to say I did it unconventionally is an understatement. I had originally bought the 3-foot section of Rohn 25 mast with the hinges on top, and I used that, it buried in the concrete to put up the tower. But as we all know, those hinges are not strong enough for what I'm doing here, and they eventually bent, and in straightening them back out, weakened them profusely. So we had to come up with a solution. I'll show you that solution right now. All right, so here is the base as it exists now. This was kind of a Rube Goldberg job, but we did it in a really good way. This is the Rohn tilt over base. What you can't see is right here is one of the legs from the existing tower base that I had in there. On the other side here, there and there, we had drilled holes to get that existing base welded to this plate. And then we put 6 8-inch long concrete anchors into the concrete. This works very well. And let's turn this around. It works very well now, and I can tilt it and raise it all by myself. But normally you would put the same tilt over base into the concrete with J-bolts to the rebar that's in the concrete. We don't have that. We have this mounted with concrete anchors only because the existing base bent and we couldn't get it out because it was buried in the concrete, but we figured we'd make use of it by welding this base to those poles. So they're welded to it, and plus they're anchored with 6 8-inch concrete anchors going into the concrete. Now a lot of people ask me, Mike, what about grounding? How did you ground your tower? Well, if you notice, on the near side and on the far side, you see about a 1/4 inch round copper, that's a number 4 bare copper wire going to ground rods. There's one ground rod 8 feet in this direction that goes to this ground wire. This ground wire, there's another ground rod 8 feet that way, another ground rod 8 feet that way, and all together you have one number 4 copper wire grounded to 3 8-foot ground rods that are each placed 8 feet away from the base of the tower. Why do we use bare copper? Because it becomes part of the ground. It's buried in the ground, it's under the grass, it's connected to the ground rod, which is also buried under the ground and goes down 8 feet. And then you have one for each leg of the tower, which is what the ARRL suggests for each one. And yeah, the best part is it ain't going anywhere. I think we're going to be just fine as far as grounding. It lowers the ability of the tower to collect static electricity the better ground you have. And what is lightning? Lightning is static electricity. One of my most popular short videos that I've ever done had to do with me filming myself in my garage during a lightning storm, asking if you disconnect your radios during a thunderstorm. I said, no, you should not disconnect your radios. And the point I made was, Why wouldn't you disconnect your radios? Well, because that gives you the ground. It keeps things grounded if you leave everything connected. Now, I'm going to get people hate me for this, but I worked for Verizon for many years, and one of the most important things we ever talked about was bonding. Bonding between electric and phone systems. Now, today everybody's got a wireless phone, everybody's using a cell phone, but back in the day, when you had hardwired phones to your house, you needed both your hardwired phone system grounded to the same place that the electric was. Why? You didn't want to have a difference in ground potential. If this ground was better than this ground, it could cause a current between them. By bonding them together, you block the ability for that current to jump across services like electric, cable, phone. So that's why you bonded everything together. It's a very important thing, bonding. People don't put enough emphasis on what that is. Now, these ground rods that I have in the tower are bonded to a ground rod over there that's also connected to the main ground rod in my house, and my main panel is grounded directly with the neutral and the ground in my electric panel. So my electric panel and my phone, my electric panel and my radios are all equally supported by ground. It's the equal ground between all of them. There's no difference in ground potential. So there's not a chance of arcing between them. Now, let me preface everything I'm saying here with, you cannot predict or prevent lightning. You can't. If you're going to get hit, you're going to get hit. And I highly suggest getting the insurance. I'm going to be getting in touch with the ARL this week because we're coming into that season where we get a lot of lightning down here in Florida. So I want to make sure I'm covered. I had a friend, my Elmer, who his house got hit, destroyed a repeater, destroyed $5,000 amplifier, a 7610 radio. Brutal. And his homeowner's insurance is paying next to nothing for the damages he sustained. And that is no excuse for that in my book. Ham radio equipment does not deteriorate. If you don't use it and it breaks, yeah, then it would deteriorate. But just existing, it doesn't depreciate at all. And he should have got the full boat for what the cost of that. Check with your insurance companies and make sure you're covered. If not, make sure you look into the ARRL insurance for your ham shack. I'm going to actually do that today myself. You can see the tower behind me. I'm not going to be doing any satellite. This is Sunday, and I'm going to be watching a NASCAR race in about an hour. So I'm going to edit this video together and put it out there for you guys, just to give you an idea how everything looks. I made a point before talking about the coax and having enough slack to lower the tower. Let me show you something else. All right, you see the winch there? That's what raises and lowers the tower. But here's all the coax and the control cables for the rotator. I found a place where I could get these rings, and I mounted them on my soffit. Let's get that up there so you can see it a little better. Here's the rings, and they run along the back of my house here, over to here where they come down. I have not trimmed out the excess. I have not trimmed out the excess coax yet, but here's my lightning arresters. I use Morgan lightning arresters primarily. And you can see a couple of these. These are the ones on the satellite antennas. You need these. You can't use those are the Morgans in the back. You can't use these on a satellite. I mean, you can't use the Morgans on a satellite. You need these. Why? Because the Morgans have a capacitor that bleeds off static electricity. These do not do that. And what that capacitor will do is if I want to use the preamp in my 9700, it won't pass the voltage to the preamps up on the mast. That's why I use these on the satellite antennas. Each has their own ground wire going to the panel in the back, which is grounded to a ground rod right here, also bonded with the electric ground in the house. All right, we'll leave that there for now. All right, so there you see the whole setup laying over on its side. I think I'm going to make a more permanent cradle for the tower to rest on, where you see the ladder out there. Also, that weather station that you see there is going to get mounted on the tower, so it's up high. Didn't have the right equipment to do it right now, but I'm looking into that, and I will pick that up. All right, so there you have it. There's a little look over of my tower and where I ran the coax and how I did it on the back of the house and the trials and tribulations of ham radio. I mean, I had to lower the tower today because we were supposed to have high winds, which really haven't materialized yet, but I'm sure they'll come eventually. But in the process, I found out the parachute cord for the 80-meter off-center fed is all messed up, and I better replace it. Otherwise, that was going to fall on my head at some point. So the good news is I saw that before it happened, and I'll replace that before I put this tower back up in the air. On that note, boys and girls, ladies and gentlemen, you know what I always say. Don't do anything I wouldn't do, at least not without me, right? This is KO4 PDI 73. Have a great day.